Okay, we're going to hit on the topic of what are called subsets, and subsets is something that's kind of a carry-on from a topic that we've had before, which is elements. So for example, if I have the set containing, say, 0, 1, 2, 3, and if I asked you if 0, and let's say that A is this set, right? So let me back up just a moment here. If I have this set, say I have set A and it contains the numbers 0, 1, 2, 3. All right, this is a set. It has the braces, the symbols there. And this set contains 0, 1, 2, and 3. And it's set A. Now, if I asked you if 0 was an element or a member of A, that would be a true statement because 0 is a member or an element of A. Another type of problem that we had was, for example, if I asked you if 5 was not an element or a member of A. So is 5 not an element or member of A? That's a true statement, right? Because 5 is not in that set. So when we've been doing these elements or members of, notice that I've had just one number, right? Now subsets, it's going to contain more than one number. Now before we get into actual examples of this, I want you to copy this down in your notes, and as I go along actually, and I've got 1, 2, 3, 4, 5, 6 different things. And as I go along, just pause this and copy it down. Now the first one are what are called the real numbers. Now the real numbers are simply every number. So real numbers is every number you could think of. It could be a decimal, it could be a fraction, it could be a negative number, it could be a positive number. Okay, any of those. Real numbers is a pretty broad topic. Now rational numbers are numbers that I simply can write as a fraction. So I can write rational numbers right as a fraction. So any number that I could represent as a fraction would be a rational number. So for example, 2 is rational because I can write it as a fraction. A negative number is rational because I can write it as a fraction. Decimals, some decimals are rational numbers. For example, 0.2. Well, I can write 0.2 as 2/10. 0.2 is a rational number. Any number that I can write as a fraction is rational. Now, how about the numbers that I cannot write as a fraction? Well, those are irrational. So I'll write down cannot write as a fraction. And probably the most popular example of that would be pi, because pi is 3.1415 ... It's a decimal that keeps on going and never repeats. So a decimal that keeps on going and never repeats, or in other words is non-repeating, non-terminating, is an irrational number. Now let me go back up to the rational numbers. Notice that we have a decimal here that stops, it terminates. Now also repeating decimals are rational because for example, I could write 0.3 repeating as 1/3. So repeating decimals and terminating decimals are rational. The other kind of decimals are irrational. All right, let's go down to integers now. Integers are numbers that I can represent in a set. So ... -2, -1, 0, 1, 2, ... Notice that integers can be negative, they can be positive. What they can't be is fractions or decimals. Now whole numbers are 0, 1, 2, ... and they keep on going. So in other words, if you took the integers and excluded the negatives and just took this part of it, that's the whole numbers. Now natural numbers or counting numbers, well, if you start counting, you start with 1, and you keep on going. And those would be natural numbers or counting numbers. Now, where this is going, and I want you to, this is the last thing I want you to write down, is let's just make a little tree graph here. So I have real numbers, which I said is a very broad topic. And then we can break real numbers into two categories. I can break them into rationals, or they're going to be irrational. Now, underneath rationals, I've got some different types of numbers that can be rational. I've got, I have integers. I have whole numbers. I have the natural numbers, or in other words, the counting numbers, right? Because all these that I had back here that we defined. Now, where this is all going then is what we call subsets. And let me connect these here. Now, subsets are actually pretty easy. So let's go through a couple examples. And I lied here. I guess I have a couple examples I want you to copy down. So let's call this example 1. Now, example 1 here, I want you to, if I have 0.62 and is an element or a member of, and then I'm going to put in braces, what subsets? So what subsets, and I'll explain what this means here in a little bit, of the real numbers? Right, so 0.62 is an element of what subsets of the real numbers? Now, is 0.62 a real number? Yes, it is. Every number is a real number. What else is 0.62? Is it rational or irrational? Well, since I can write it as a fraction, it's rational. Is 0.62 an integer? No. Is it a whole number? No. Is it a natural number? No. This is what we mean by what are the subsets of the real number. So 0.62 is a real number, it's a rational. So these are the subsets of what we're talking about. Let's go over another example. Let's take example 2 here. On example 2, let's say we have a little different type of number. Let's say we have 2 radical 2. And let's ask ourselves, all right, what subsets, same question, what subsets of the real numbers? Like that. Okay. Now, again, you're always going to start off with real numbers, right? Because any number is a real number. So it's real. Now, is it rational or irrational? Now you need to take your calculator, and if you took the square root of 2, you're going to get a decimal that probably doesn't repeat and it doesn't end. So I'm going to do that, and I'm just grabbing a calculator here. So if I take radical 2, and you do the same, and I get 1.414213562. You get a decimal that doesn't end and it doesn't repeat. So this number automatically is irrational. Like so. Now let me go over one last example. Suppose that we had, and let's call this example 3, and I'm going to stick it up here. How about if you had, I'm trying to think of a good example. If you had 3 1/3. Right? Now, it's real. Is it rational or irrational? Well, can I represent this mixed number as a fraction? Yeah, because if you remember how to do that, you take the bottom number times the big number, the whole number, you get 9, and then add the top, so you get 10/3. So 10/3 is a fraction, so it's rational. Now, is it an integer? No, because there's a fraction involved. Is it a whole number? No. Is it natural? No. So it's real and rational. Just something to think about. How about if I ask you the square root of 16? What is the square root of 16? It's 4. Can you represent 4 as a fraction? Yes. So this number, radical 16, would be real, it would be rational, it would be an integer, it would be a whole number, and it would be natural. So here's an example where this number is a lot of them. It would be a subset of quite a few of them. So the topic is called subsets. It's kind of a carry-on of elements or members of.